now we're going to look at some things we can do with these tiles. And what we are going to generally do is set up equations to solve them. So we're going to model and solve, in this situation, one variable and one-step equations. So I'm going to get another piece of paper, and I'm going to fold it lengthwise so that I can draw pictures and write symbolically what's happening as I do it. And what I do, you definitely want your students to be doing so that they can connect concrete, pictorial, and symbolic together as we go. All right, so I'm going to just set up a really basic equation. I'm going to write down the equation over here on my symbolic side. Let's just set up 3 plus x equals 4. Something really easy. The students will know how to do that. And now what we do is we have to figure out how with our algebra tiles to model this equation. So that 3, remember our little ones? Those represent 1 each, so I need 3 of them. And then the bar represents x. And then we need 4 little ones on the other side of the equation. Now I've seen a lot of ways to do this, and you're free to do it any way you want. You can have a little equal sign that sets here in between the two. I just have my students put their pencil there. Colored pencil, ruler, whatever, so that this represents that this is the left side and this is the right side of the equation. So once we built it and we talk about how to build it, we'll have our students draw those tiles in a nice pictorial model, and you might draw the line very long or all the way down. And does it matter if they go sideways, up and down? Doesn't matter. It's okay. And in fact, with this standard, we probably want to use a couple of different models. So do we all agree that we have 1, 2, 3 and x equal to 1, 2, 3, 4? If they agree, then you can move on. Now, they're going to know that all I need to add is 1 more to this, but that's okay. What we want to see is how to do that over here. So we go back to our physical model. The kids have to use these physical models, and we say, how can I, or what's the goal here? The goal is to get this x all by itself, x alone. We want to end up with x equals something, right? So we want the x bar alone. So we want to end up with our x bar and then the line and then something over here, right? So we know already this answer, and they're going to know this answer, but let's go through this exercise with something we know. Now, how can I get this x alone? How can I get rid of these 3? That's the question. And how can I do it in a fair way? So perhaps someone will say, well, you can just move them off. And really, that's our goal, is just to pull these 3 off. But the problem is, an equation is something that is built on fairness. So if I take 3 away from the left side, it's not going to be fair anymore, is it? And I always say, you know, if you have a brother or sister, if your mom takes $3 away from you, shouldn't they take $3 away from your brother's allowance too? Or you can do the scales, the triple beam balance, where you have equal quantities on both sides. If you take something off of one side, it's going to be in balance. It's not going to be equaled anymore. So if I take something from one side, I have to take the same thing from the other side. Otherwise, I don't have balance. So I can take 3 from this side, but I also have to take the exact amount, which is 3, from this side. Does that make sense? So let's see how we might draw it. And again, it's up to you how you guys decide to draw this thing. When I take 3 away, I draw a circle around it and an arrow. It's gone. Some people exit out, whatever you guys want to do. But if they do it this way, you can see that they meant that they took an equal quantity from both sides. Now we want to follow that up with our symbolically what's happening. So we'll subtract 3 from both sides of our equation. And I like to draw a line. A lot of controversy over how you represent this. It's up to you. 3 take away 3 is 0 plus x, and isn't that what I had left over here, equals 1. Do we agree that this matches this picture, matches this symbolically? And then knowing our identity property, that anything, a 0 plus anything is just 0, then we can say x equals 1. And we have, in the end, the picture we were looking for, x bar over here, 1 over here, and we have our answer. Does that make sense? Okay, that was an easy one. Let's do a different one-step, one-variable equation. Okay, grabbing another piece of paper, folding it. All right. Now let's do one with a difference type. Let's do 3 is equal to, let's do 3x is equal to 4. So for this equation, we're going to have symbolically 3x is equal to 4. We're going to draw our picture. Of course, these should all be the same length, but we get a little tired when we're drawing our squares and our rectangles. And the kids will be okay if you're okay with them getting a little sloppy, and I'm a little sloppy, and it's okay. All right, so we have our physical model, pictorial model, symbolic. Now, in this case, I don't have one x. My x's are isolated on one side of the equation, but I don't know what 1 means. This is something that we need to kind of get to that idea of, I need to think about these maybe as like our team captains. We have 3 team captains, we have 4 players, and we need to divide them evenly to be fair again. So I can start dividing my tiles, and I have 1 for you, 1 for you, 1 for you. I'm in good shape, except for this little tile here. So if I had 3x equals 3, I can see my solution right here. 1x is equal to 1, or each team captain gets 1 player, right? But I threw this extra one in here for fun. So if I were to divide these up and I say this one goes to this one, this one goes to this one, this one goes to this one, and I have 1 left, how am I going to divide this guy up evenly to go with all 3? Well, I can draw it on paper. I'm not going to break my tile, and I'm not going to write on my tile because I want to keep using it. But I can draw this. So how many equal pieces do I need to have of this tile to be able to divide it 3 ways? Well, we need to have 3 pieces. And since together they make a whole, we have basically 1 tile divided into 3/3. So does that tell me now that I can take this and I can say plus 1/3, plus 1/3, plus 1/3. And then to show what we've done, we say each x is associated with 1 1/3 tiles. Okay? So I've changed that in and moved that up. Those are all been moved up. So then my final answer is 1x equals 1 1/3. What do you think? So we can even do fractions with tiles, sort of. So symbolically, what have we done? Well, we took this 4 and we divided it into 3 separate groups. And when we did that, we also divided our 3x's into 3 separate groups. So that's just the essence of division, right? So 3 divided by 3 is just 1x equals, and then we can write 4/3, or we can have our students change this into a mixed number of 1 1/3 so it matches our tiles. Does that make sense?